In this video, we're going to begin developing the idea of a unit circle. So the definition of a unit circle is simply just a circle where the center is at the origin at the coordinate 0, 0, and it has a radius of 1 unit. So consider the coordinate grid, and let's place the unit circle in it. So the unit circle has a center at 0, 0, and since the radius has a length of 1, so the circle is going to intersect the axis at the following locations. At 1, 0, 0, 1, -1, 0, and 0, -1, resulting in a circle in the coordinate plane. It looks like this. We will define some of those other points further later on. Let's talk about the circumference of the unit circle, because this is going to play an important role in converting between degrees and what we call radians. Recall that the circumference of a circle is 2 times pi times the radius. Since the radius of the unit circle is 1, the circumference, the distance around the unit circle, is 2 times pi times 1. So the circumference is 2 pi. So let's talk about the idea of radians. An angle will have a measure of 1 radian when the length of its arc that it intercepts is equal to the radius. So essentially, the idea of a radian is, imagine if I put an angle in the unit circle, just a random angle, so let's call it theta. If this arc length was equal to the radius, we would say that this is 1 radian. We know in a circle, the distance all the way around the circle, we would call that angle, or that there's a total of 360 degrees in the circle. Since that arc length would be the same thing as the circumference, the length all the way around the circle is equal to the circumference, which is 2 pi units. We say 360 degrees is the same thing as 2 pi radians. So let's talk about how we convert from degrees to radians. Since there's 300 degrees in a circle and we say that that is equal to 2 pi radians, we could actually divide both sides by 2 and come up with the fact that 180 degrees, 360 divided by 2, is equal to pi radians. 180 degrees equals pi radians, in the same way that 360 degrees equals 2 pi radians. So let's talk about how we're going to convert that to radians. We're going to use a proportional relationship. We're going to use the fact that 180 degrees equals pi radians. So imagine if I wanted to convert 45 degrees to radians. Then what we're going to say is 45 is to 180, as we don't know, is to pi. Notice how I put degrees is to degrees, as we don't know, we want to know radians, is to pi radians. So we're just using a proportional relationship. So let's solve this for x, because that's what we want to know. The angle in radians that's equivalent to 45 degrees. To solve this, we would need to cross multiply. 180 times x is 180x, and 45 times pi is 45 pi. To solve that for x, we would divide each side by 180. X equals 45 pi over 180. And if we wanted to simplify that, we can divide 45 and 180 both by 45. So we get pi over 4. That's pi over 4 radians. What that means is 45 in degrees is the same thing as an angle called pi over 4 radians. To estimate that to 3 decimal places, we can use the pi button on our graphing calculator. To use the pi button on a TI-84, you're going to hit second, and then the button above the division sign is like a little caret. You'll find the pi symbol there. So you'll hit second and that caret button, and that will bring up pi. And then divide it by 4, and you'll get 0.785398, and so on and so on. So if we round that to 3 decimal places, we'll get 0.785. That means the length of the arc intersected by 45 degrees, or the length of the arc intersected by pi over 4 radians, has a length of about 0.785 units. So pi over 4 radians is approximately 0.785 to 3 decimal places. After this section, we'll only be using radians. The idea is just that you understand about the length of the arc that's being intersected by pi over 4. So let's do the same thing now for 520 degrees. We're going to say 520 degrees is to 180 degrees, as the angle we want to know, x, is to pi radians. We're going to cross multiply. So 180x equals 520 pi. Dividing by 180, x equals 520 pi over 180. We can divide both of those evenly by 20. And so what we'll get is 26 pi over 9. So x is 26 pi over 9 radians. So 520 degrees is the same thing as 26 pi over 9 radians. And to use the TI-84 calculator, we want to do 26, then multiply that by pi. That will give you a number divided by 9. The result will be 9.0757. So rounding that to 3 decimal places, the 7 next to the 5 is telling me to round that up. So 9.076 radians rounded to 3 decimal places. So let's just briefly talk about how this relates to the unit circle. With the unit circle, there's key check-in places. In degrees, we start at 0, 30, 45, 60, and 90 degrees. The unit circle continues on in those same proportions. We now know how to complete or how to convert from degrees to radians. If you were to do so, in the upper right quadrant, the result would be 0 degrees is 0 radians, 30 degrees is pi over 6 radians, 45 degrees as we already found, is pi over 4 radians. And 60 degrees, pi over 3 radians. 90 degrees is pi over 2. And so we could actually complete all the degree measures and all the equivalent radian measures using that conversion that we did in those previous two examples. The result will be this unit circle. This completed unit circle is available for download directly underneath this video. You're going to want to have that unit circle so that you can reference. But the idea is that when you see this 30 degrees and this pi over 6, that is referring to this angle measure. 30 degrees is the same thing as pi over 6 radians. And we can now convert from degree measures to radian measures. So now I would suggest printing out this unit circle if possible, or if not, having this available for reference. In the next video, we're going to discuss those coordinates and how they relate to sine and cosine.